Hello everyone. So that's the industry speaking here. BACS stands for the European Association of the Building Automation and Controls Industry. So let's see how that works for me now. And I will try to show you. Exactly. These are the EPBD compliant capabilities of the building automation system. So I will use BACS from time to time just to be shorter instead of saying 4 words. So which are they? And these systems have to meet all of them, not just selective one of them. They have to actually comply to all this. And we have the monitoring, analysis and adjusting of the energy usage. That's the first one. Then the benchmarking, detecting inefficiencies and informing the operator about it. And the third one is to allow communication between the different technical building systems and the interoperability with other systems and appliances in this building. So I'm really curious to know in the audience how many people know about EN 15232, the European standard. Have you heard about it? Okay, very good. Sorry, it's, oops, now I'm too fast. I wanted to talk about the, why did I mention this European norm? Because, all right, I'm sorry. You're intervening, that's manual override. Okay, very good. This is what a clever, smart system would do. It would say, aha, someone is messing up with the system. So why am I mentioning this standard, 15232? Because actually the standard capabilities of a building automation control system are listed there, they're defined. And each function has 4 energy efficiency levels from A to D, with A being the one with the highest efficiency level. Now, when we are looking at, and I'm not going to try to change this, about the capabilities that the revised EPBD is asking for, ballpark, we would say typically any system that can meet the B level and above in all integrated systems in these functions, then it should be capable of what EPBD is requiring. This one is the energy demand and supply model on which actually the norm is based. And what you see here, the rooms are creating the energy demand, so the space. In order to satisfy these conditions, we have to use suitable technical building systems to provide these conditions. And the technical building systems are the generation and distribution systems. Now, if these systems are providing just the necessary energy to meet the requirements, then this is the so-called demand-based control of technical systems. And that would be the most energy efficient way of using the system. Now I will try to change again. And then we can talk about functionality actually in 3 different groups, so to speak, which is generation, distribution, and emission in the space. And here you can see these same groups. This is at room level, and you can see how many functions there are in the emission control in the rooms. So you have to really coordinate the provision of cooling, heating, air, ventilation air, with different technical systems, then the shutters and the lighting. And all this is happening at the emission level. And from here, that should dictate how much we actually, how much energy we generate and we distribute after that. So the generation is the cooling and heating and ventilation, of course, and the domestic hot water. What else you see here is this box up here, which is the technical building management. And the implementation of these functions actually ensures the interaction of the different technical building systems. It also provides information to the building operators. So this is a pretty important box. All these numbers that you see, they actually correspond to the function number in the European standard that I have already referred to. Okay, now I'm going to go back and try to address in a bit more detail what it means. What are the capabilities, the functions that the building automation system should possess in order to meet the revised TPD requirements? So I will dedicate a slide to each one of the groups. For example, for the continuously monitoring, logging, analyzing, and allowing for adjusting energy usage. What the system should be able to do is the continuous monitoring of the actual values of energy consumption, system operation, and the indoor environmental parameters. System events and diagnostic data are logged. Then you use this actual data and trend information to detect change in patterns, because when you have trends, you can compare. Then the set points and the run times can be adjusted individually from a central location, and that includes also preconditioning phases. So when I talk about preconditioning phases, I mean about pre-comfort or standby, for example. These are the different modes of control. And then you can adjust each one of these set points individually. And then, of course, you have the individual room control, which should be communicating in order to communicate to the generation part of the systems. I need it now. That's my demand. And then you minimize the losses in generation and distribution to a minimum. And I just want to say once again, the previous slide where we had all these numbered functions, actually these are functions that they're not in a dream, they're standard building automation system functions. Any decent building automation system should be able to provide these functions. The problem is only how they're used. This is where the problem is. So let's go further with the group B on the benchmarking and detecting losses and informing the person. So benchmarking, and I'm just giving examples here, it could be anything though. Benchmarking of actual efficiency, that could be against design specifications. So if it is designed how it should be performing, then we can benchmark against that with actual data. Or a previous period, or values from other buildings if you want to benchmark on a building level. Then for the detection of losses, the system events and alarms are logged, and they should be ideally at a central location, which is usually the building management system. So the operator has on one screen everything that he needs to know. Sometimes there is a problem with this because, again, that has to be defined. Which alarms are important for this building? Otherwise, per default, you're going to get faults and alarms on any piece of equipment in this building, on any component, per default. So you're going to have probably an inundation of alarms. So here, the mastership is to define which ones do I want in order to be able to monitor and optimize my building as well. Maybe I want to monitor specific things in the systems and then set triggers. You can see the next point. Set triggers to alert then the operator, I'm out of limits on this specific parameter. And then supports the diagnosis when deviations are there. So there are systems with advanced analytics that actually can give you some recommendations, suggestions, what might be wrong. With the group C, communication, this is basically what a building automation system does anyway. Integrates different technical building systems and controls them in a concerted way. So the information is exchanged, and then you don't have, for example, fighting between heating and cooling, which is still very, very common. Straightforward, but very common. Then room automation is networked. And then the interoperability, of course, this is ensured if the industry communication protocols are used, like BACS, for example. So if the other pieces of equipment or systems in a building could use common communication protocols, then there shouldn't be a problem for interoperability. And usually our control devices have 2 or 3 or more communication protocols just to fit, to have open protocol communication.
Is this somehow aligned in the EPBD? There will be one and it will be BACS?
No, EPBD, it's only a directive, only at the direction where you should go, but this should be in standards really, not in a directive from the European Commission, which one. And again, I mean, you have so many existing systems out there. Actually, the majority are. So we have to use the renovation cycle in order to bring this.
Another question. There are 2 systems, and these are different manufacturers, and who decides who is the supervisor in here? Like, how does this directive approaches the different systems have different controls, and there should be one that says, "Oh, you are not heating because I'm cool."
So you're mixing technical requirements with political, so to speak, narrative, or how shall I put it, direction. Why are we doing this? So really, in this case, anything that happens in a specific building, it's the owner that decides. Okay, and if he or she cannot decide, then they engage a consultant, and this consultant should be able to specify which one is the supervisory one. That's the solution in reality, really. It has nothing to do with the EPBD or any such things. It's really the technical requirements and the implementation requirements. And someone is responsible for the operation of this building. This someone should decide this and this system should be there, I'll pay for this, I'll buy, or I'll replace, or whatever. But it is really there.
So in order to be compliant, there must be someone who's actually skilled in this area and says this will be.
Yeah,
if I'm doing this and I'm certified to do it, then this BAC is
meeting these requirements. Yes, yes. And as can I say Paul? Yeah. He already mentioned that actually it is in a process of transposition. I mean, all these things, not just building automation implementation. So it depends at the local level how a member state would implement this, how they would decide to approach this.
And the outlook is there will be some certification. There will be some certification of surgery that does this.
That's left for member states to decide how are they going to do this. Whether
yeah, it's okay.
They could do it in different ways. They could establish the certification authorities, or they could certify companies, for example. It's really up to them to decide how they're going to determine that indeed buildings over a certain size have this type of system installed that comply with these requirements. It's really up to them to decide, because at the end of the day, they are the ones that are going to have to control.
Okay.
And then they have to explain to us.
Yeah, so I just want to emphasize once again that it is an inherent quality or characteristic of a building automation control system to actually do the interdisciplinary orchestration of the technical building systems in a building. And on these slides I just showed some of the so-called interlocks. If you know what an interlock is in a control system, is when you actually make things dependent on each other. Like, for example, interlock between heating and cooling control. And by the way, what you see here in the boxes, this is exactly the text from the European norm. This is what the functions are called. And then they have different energy efficiency levels, as I mentioned. Sequencing of different heat generators, free mechanical cooling. So if you have cooling, you might use your chiller plant, or you might use free cooling coming from the ventilation system. That has to be coordinated. So then also this technical building management part, the box up there, this is just one of the functions, and you can see detecting faults of technical building systems. This is just an inherent capability. This is something that the building automation system is supposed to do. Okay, so let's go further. I'm going the wrong way. I can see that. Come on. That's the end of my presentation. Right. Can you help me, please? One up? Yeah. No, up? Yeah, exactly. So, the EPBD is about the energy performance in buildings. But actually, the benefits from a building automation system is not just in the energy performance. It of course comes with the accurate control of the indoor environmental conditions, which I showed before, at room level, which of course contributes to the productivity, increases productivity of office workers, for example. Of course, it has also a sustainability side in it, not just energy performance, indoor environment. It reduces the costs or raises the operational efficiency. And how does it do this? If the system informs the operator in advance, well, not in advance, but when things happen, go wrong, or inefficiencies, then the operator can actually react. They can address these things before it incurs operational costs or energy costs in time. So this is what we're talking about ongoing. Well, I'll touch on this later on. Not regular, we are talking about continuously doing this. That of course enables continuous optimization of the performance, and at the end of the day, the building automation system supports the image of a smart, efficient and a healthy building, which is of quite a big value to the building owner. because in the future, I believe, especially with the smart buildings, these buildings will be like, let's say, the LEED buildings or BREEAM or any other labels that we have around. But if you have proof that you are in a smart building, then that would raise the value or maintain the value at least of this building. And what I wanted to show in the next one, plus the energy flexibility. This is another thing that is supported by the building automation control system. So, in the words of stakeholders, or the main stakeholders in the building, that's what I would imagine they would say. So, a building operator will say, okay, I know the performance of my technical building systems, and I feel I'm in control. The building occupant will say, I feel comfortable and I can concentrate on my work. I don't have to worry because something's blowing in my neck, or I'm cold, or I'm hot. And then the building owner, I maintain the value of my building and I'm ready for the future. So, of course.
What does need to be said about the indoor environment? Well, does it say something about the parameters you should monitor or
no. It says that we should monitor the conditions, the indoor conditions, but does not go further into comfort or productivity. There are a few mentionings in, I believe, what you call this? They're not paragraphs at the beginning. They're called something special. Exactly.
But standardized this energy you're talking about, that goes further than the requirements.
I'm not talking about.
I imagine that the temperature monitoring or CO2 or somewhere must be defined. Experiments.
No, it's not. Again, it's not in the directive. So this is again technical requirements. Yes, and it depends on the member state how they'll transpose it. So they can say, we are going to monitor this, this and this, specifically. That would be the implementation then.
I'm just an absolute killer on BACS and I think this is only about the building perspective.
It is, yes.
Or is it also home energy management systems?
If you have an automation, let's say home automation system, you could use it. It will provide you probably with the same benefits. What EPBD addresses and where the building automation control systems will be mandatory by the 25 is buildings with 290 kilowatts rated output. Okay? And this is only in heating and ventilation. Okay, so yes, they have to be of a certain size to really make also the investment working. Yeah.
I have a related question. You mentioned the parameters. They are somewhat specified for the member states. Will it be in the guideline that will be published?
Which parameters they have to?
I mean, some guidelines. What should the member states do? Like
which temperature? No. Sorry,
please.
The directive is only about the energy performance of buildings, and it sets guidelines, principles, and requirements on how to achieve the energy performance of buildings. What this performance has to achieve in terms of comfort. So systems have to do a job, basically, and the EPBD sets requirements on how efficient they are doing this job. But the job description, which is temperature, ventilation levels, etc., that's really outside of the scope of the directive. The directive only says you have to do this job very well.
In other words, is there any source of information where you would get the idea what the future will be?
In terms of
in terms of the requirements for the BACS.
So what you could do is probably you could find out in your country who is defining this transposition? Okay, so there is someone in this country that's doing it.
So
and
there's
then
no central guideline for this.
no, not at European level.
We are going to publish a set of recommendations on modernization of buildings, which will provide further information on how to interpret these requirements, these provisions. But it's not a set of specific technical parameters, yes, that have to be done. It's more to help member states on how to interpret the directive. It's a recommendation between the Commission, by the Commission for the member states, but of course there is also benefit for stakeholders.
There are too many countries with different needs, so it's not possible to do best practice recommendation.
So best practice probably could be exchanged at a later stage anyhow after the transposition has happened, so after March next year, perhaps.
We are ready to do it.
Very good, okay.
Perhaps
yes.
so much, to answer that, there is a European standard in 50,251. It sets criteria for temperature, etc. It is also referenced in the EPBD standards. But that's not European legislation. You can find suggested input parameters.
Yes,
That's one to highlight. So, if we have such a question like inspections, or let me say, or building automation systems which fulfill requirements based on somehow inspections, we should not look only at one or two standards which are guiding us to that topic. Everything cannot be fulfilled with one. So we have the 16798 part 1, which is dealing with the indoor environment quality aspect. So if a system should fulfill that, it should also consider this issue. We have other standards like 16798 part 3, which is dealing with the performance of ventilation systems, for example, or room partitioning systems. So which also guiding some things. And we cannot look isolated on that functions. I think one of the points is how we link 5232 to all these others, and what indeed, on national level, regional level, or I would say better European level, would be, I would say, indicators and benchmarks. So I think on all that you showed on your slide 2 that there should be fulfilled on this B aspect, that it fulfills some checks internally in the automation system. But I think there is a need to specify, let me say, some guidance. What shall be checked? How should a building management system check itself?
Exactly.
If, for example, a demand control has not been foreseen during the design phase, and at a later stage it is, let me say, beneficial to have demand control because using the building change. So I think there should also be implemented a principle to let me say, to guide the way how we also have to manage this building automation system, that it fulfills this requirement on energy performance. So I think this preferably should be done on European level, or maybe I can give some further indication, but I would like to initiate some things, how we really describe such a procedure.
Okay, but we have an overview of all the mandate 480 standards. There is a session, I think, tomorrow morning on this, on the energy performance of buildings standards, and they all relate. And you can see how, for example, the 15232, or there are other standards as well, the one for the building management system, for example, how they connect to the others. So this is already as a framework there. But really, the implementation or the specific technical specification should be, for example, in the building code of a member state. And this is not what the European Commission can do. Okay, so if you refer in the building code, you say, this is what has to happen, these are, or the parameters are defined in the standard that you just mentioned before, I mean for the indoor environmental conditions, and you basically refer to these relevant standards, same with ventilation systems and whatever, and EN 15232 as well. in this whole framework, but it has to happen at that level. Okay, I have to finish this because my last slide is very important. It's okay. No, I'm very happy to chat with you. It's just that I really want to bring my message across, and then we can talk. I'm here tomorrow as well. So that's the question, the one, how do we actually recognize the systems that can do this? The one that really comply to the requirements of the revised TPPD. And this is just one example. So you can see here you have the monitoring of different parameters. One is outside air temperature, return air temperature, then you have the compressors start and stop. Okay, so you simply look at 3. So this is group A requirements, if we take it this way. And then group B, it actually says, okay, the outside air temperature is lower than the return air temperature, but my compressor is running. So something is not that efficient really. And if, depends on the circumstances, so if it is a fairly new building, let's say, and that has been operating properly before, this specific control sequence. So if the outside air temperature is lower than the return air temperature, then I don't run my chillers. I use the free cooling. Then there must be something wrong with, well, airside economizer, that's what's called in America, but that means, in this case, the dampers, something's wrong. So first thing is, go and check what that is. And now the group C requirements is, yeah, you're monitoring different systems, you're controlling different systems, there is clear interoperability or connection, communication between this. Now, if you want to recognize this, you can simply ask for an evidence like this. You can say, I want to see in this building this and that. Depends in which role you are. If you're the consultant, you should be able to, because you ask for something like this, or a building operator. If you haven't asked, then you know, we can run as many of these as possible, humanly possible. But in order to really achieve energy performance improvement, that has to be defined. What am I after? What do I want to monitor? What do I want to benchmark? What do I want to optimize? And the building automation system monitors and controls the key energy consumers in a building. So, okay, so I should have asked the question, but this occupies my attention too much. Doesn't that sound like ongoing commissioning to you? All these things, monitors and manages and controls and all this, continuously, on a continuous basis. So this is what would happen if you have this ongoing commissioning, or you can call it monitoring-based commissioning, or you can call it continuous commissioning. It's all the same. The matter of fact is you monitor non-stop. You monitor actual time, real time, and you get maintained performance of the technical systems and the building. Now, if you don't do this, if you don't do the monitoring piece, the systems will deteriorate with the time. The performance will deteriorate. It's simple tear and wear of mechanical systems, for example. But there is also this operators, human intervention. So there are the manual overrides, changing set points, changing run times, and so on. And sometimes most times people change something and then they forget to put it back, for example. So you can build in your control sequence to override, for example, change set points. If it's manually changed, after 24 hours it goes back to the one that was according to design specification. And then, of course, these yellow ones, just if you have, maybe we can compare it with, this is really the retro-commissioning or recommissioning. You can compare it with regular inspections in a way. So it happens now and then you always climb a hill and go down a hill, and it goes like this. So at the end of the day, the minimum energy consumption would be if you use this green bit. There are some studies that say that for the deterioration of the energy performance, it actually happens up to 30% in the first 3 years of operation of the building. So it is important to monitor what's happening and maybe fine-tuning all the time. Because once you have the building in use, and not just as installed, or as built, as we call it, once you put the little men inside, and women, and they do things, then it might get out of hand.
So I just have a very personal question, very basic. What does BACS stand for?
Monitoring-based commissioning. Okay. So, going back to inspections, Article 14 and 15 in the revised EPBD. I just want to compare what a regular inspection and an inspection using building automation, what are compare the different characteristics. So, with the regular inspection, you're doing an isolated system. You're inspecting a system, a specific one. And in the past, actually, according to the previous CPPD, it was only the boiler, or maybe that's how they interpreted it, I don't know. Now it's clearly written it has to be the system, the heating system, and not just the boiler. But it's still isolated. So if it's the only technical system in the building, that's okay. But I doubt it would be nowadays. Because at least you would have another ventilation, for example, piece there. I'm not going to go to the right, you can read it yourself. Here the comparison is about actual performance and real-life use conditions. So when you do a regular inspection, you have to basically subjectively determine what is a typical operating condition. And you take some value. Here you have actual data and it's real-life use conditions. Then we have at a certain point of time, and this is ongoing, and then once a time consideration, if you remember the yellow line in the previous slide. So, yes, you're a good citizen, you do your inspection, you do your recommendations, you implement these recommendations. Then with the time, it will go down. And again, you do the next one, you go up, you go down, and so on. Here, you might make very small fine-tuning steps in the operation of your systems, supported by the data and the information that the building automation system provides. So that might be much less painful to do. Small fine-tuning, tweaking things, rather than in big steps coming and saying, okay, now you need this and that. And of course, from time to time, you would need renovation or refurbishment of your systems, because they last shorter than the life of the building. That's normal. Okay. I have a lot to say, but I think I should probably finish. One important thing is the impact that has been assessed of actually using the building automation systems. If you have a building automation system, the annual energy saving would be up to 20.3% of the whole service sector. This means non-residential buildings. And the return on investment or the payback is actually short, between 1 and maximum 3 years. We are talking about buildings with a size to 90 kilowatts, yeah, and above. So I'm not talking about every little hut in the mountain. I just wanted to read one quote from the Facility Managers Association, emphasizing on the word tool. So, building automation and control is a tool for operating, adjusting, switching, controlling, monitoring, analyzing, and optimizing building services. BACS forms the core of an integrated facilities management system covering other building-related services such as access control, security, fire safety, energy monitoring, remote supervision, and maintenance. That's the quote, and I think that's the last slide now. So, in conclusion, I'd like to say that physical inspections were yesterday. We are now marching with, I wouldn't say big steps, but definitely marching already in the direction of digitalization. There is no way back. We are going in this way, and we need the smart technologies in order to help us to achieve what we want, not just in energy performance, but also in actually having us as active players in the energy system. So today, the BACS is used to continuously monitor, detect, analyze, and inform on the performance of the technical building systems. And that is in order to enable tomorrow. And tomorrow is when predictive maintenance, self-learning systems, or if you want, artificial intelligence, digital twin, and the buildings as prosumers will be facts. Thank you for your attention. And if you have any questions,